This is FE Peer Review, and it is still November the 9th, 2021. Cool Moonlight and the Enigmatic Flat Earth Map. Yada, yada, yada. You know what to do. This evening I came across this very nice little video by a man's channel named Plato Platt. He was describing his analysis of his observation of the moon and how it led him to conclude that the moon is indeed spheroidal, with craters and reflecting the light of the sun. It was a very nice little video, gave rise to some interesting comments, and one comment that I felt obliged to respond to. Super Dave writes, "This is great. Now explain how it gives off a cool light. Please also provide an actual scale model of the Earth, Moon, and Sun. Globetrotters had 500 years or so and still waiting." Well, I will try to resist the temptation to mention that we are also still waiting for an accurate to scale map of a flat Earth. But anyway, like I said, I'll try not to mention that. So my response, I quoted Super Dave, "Explain how it gives off a cool light." The moon gives off cool light? ? I have yet to see evidence of that. I've seen the videos where people go outside at night, measure temperature changes under the open sky and under a shading object, and measure a difference. But the same thing can be observed on nights of a new moon as well, when there is no moon in the sky at all. So this clearly points to some other reason other than moonlight as a cause for the cooling, since it happens even when there isn't moonlight. In addition, another phenomenon is extremely well documented and thoroughly understood, which does explain the cooling. It's called night sky radiative cooling. It has many practical uses. There's a .com website called The Grider, which has an article entitled, so I'm making this video now because I wanted to refer to several other websites and can't put links into YouTube comments. So I thought, why not just turn this comment into a video itself? So I'm going to be going to these other websites and putting the links in the description and so forth for this video. So that was touching on the moon gives off a cool light. I avoided going down a tangent here, which was that night sky radiative cooling is actually, like I said, it has many practical uses, including in the world of architecture, when sometimes rooftops are flooded with flat roofs are flooded with a thin layer of water at night, which cools off rapidly, and in so doing cools the roof of the building. And this can actually be used in desert climates to cool a building so that when the day starts, the building is very chilled in essence, and has more capacity to absorb heat from the hot day without overheating. So there are many uses for radiative night sky cooling. I'm sure there are others I don't even know about. Onward, quote, "Please provide an actual scale model of Earth, Moon, and Sun." And he suggests in his comment that such a thing does not exist and globetrotters have had 500 years or so to produce one. Well, okay, a scale model would be interesting, but is not in itself evidence for anything. Yeah, sure, we could make a scale model, but whether we do or don't doesn't mean that that's is or isn't the way the universe is shaped. I mean, the universe is shaped however the universe is shaped, whether we're here to even make a model about it or not. So I don't see the need for a model. However, there are some real practical problems with making such a model. The following link and video explains the necessary size of the sun. I will go to those links for you. It's an Exploratorium link, which is in San Francisco. It's a great institution, the Exploratorium. Great science exploration place. You can also see the .com website Data Genetics and search the article Space is Really Big. It points out that if we scale Earth to be the size of a tennis ball, the sun would be 783 meters away. That's 7 football fields away. That said, there are some scale models. Now, I have a childhood memory. I'm going to go back to my comment here. I seem to recall one built alongside a highway, either in Southern California or Arizona. It was there during my childhood, covering a distance of several miles. But I don't know if it exists anymore since I can't find mention of it online. I remember seeing it when I was a kid. We'd drive down this long straight highway through the desert. desert. What's the name of that desert down there? The border between California and Arizona. Death Valley. We'd be driving through Death Valley, and there were these signs along the road, and it went on for several miles, and it was all the different planets until you got to the sun. It was quite fun. Anyway, at Tennessee Tech, they created a scale model on their campus each year. Last year, due to health restrictions, they created a, quote, virtual model and a video about it instead. You can find that here on YouTube. I will show that video in a moment. I have a PDF file documenting the Tennessee Tech scale model from 2019. So I will put a link to that document in the description of this video if anybody wants to see it. It gives a map of the Tennessee Tech campus and explains where the various objects are and their sizes, and everything is done to scale. All right, we're going to explore this a little bit more, but I'm going to pause it here. Okay, back to radiative night sky cooling. I'll be quick with this. So, of course, there's a Wikipedia page that touches on it. The section called Nocturnal Surface Cooling is worth a glance. There's also an interesting article in Popular Mechanics magazine website of some very clever inventors who found a way to make this little black disc, which cools in the presence of the night sky. And then it says here, scroll down a little bit, the team then used the black disc to radiate the heat given off by the surrounding air. A thermoelectric generator, which produces electric voltage in response to a temperature difference, converted the heat into electricity. So under the night sky cooling effect, this disk, which is warmer than its surroundings, is giving off heat to the night sky. And that temperature difference, they have a way of harnessing that temperature difference to get electricity. And they were actually able to turn on an LED light bulb with that. So there you go. There's some interesting stuff. Now I have a little challenge, kind of, not so much a challenge. Anyway, something for those of you who are interested in the idea that the moon gives off cool light. We've all seen videos people have made where they go outside on the night of a full moon and they measure some temperature in the moonlight, and then they go underneath some kind of shade structure, a bush or a tree or a porch or something, and they find that the temperature is warmer because they are not in the direct moonlight. Well, here is my little challenge. Do that. Do it very meticulously. Take several measurements, and then do that again on a clear night when it's a new moon. No moon in the sky, no moonlight at all, and a clear sky. You do that on a clear sky on a moonless night, and you will find that you get the same effect. It's cooler under the open sky. Now, if it's the same effect, whether there is or isn't moonlight, then can you reasonably claim that moonlight is the cause of that effect? I don't think so, especially when other causes have been thoroughly explored and are now being used. Okay, so that's enough about radiative night sky cooling. This here is a little article from the website called Data Genetics. Also, we'll find the link in the description. The Earth as a tennis ball. If the Earth were the size of a tennis ball, the article is trying to give a sense of scale here. If the Earth was the size of a tennis ball, the moon would be the size of a marble, and it would be 2.02 meters away from the tennis ball. And then the sun would be 7.3 meters in diameter. And the distance from the Earth to the sun would be 783 meters long, or 7 football fields. So imagine yourself at one end of a football field with a tennis ball in your hand. 7 football fields away, there's a balloon measuring 7.3 meters in diameter. What's that in feet? 20, about 25 feet roughly. 25-foot ball at the end of 7 football fields would be the sun, and the moon would be about 6 foot 8 inches away from you, and it would be the size of a marble. So there's a little bit of scale for those of you who may not grasp the issue. This is an article from the Exploratorium website, link in the description. These two folks here are showing you again scale. The woman over here is holding Earth, and to scale, This little circle right here is the moon, and this is the distance between them. And then he also goes on to discuss the size and distance of the sun based on this scale. And this little PDF here is a summary about the 2019 scale model of the solar system that was constructed on the campus of Tennessee Tech. They make it and take it apart each year as a part of the Astronomy 101 class. So last year they did not make the actual physical model because of the health issue that was everybody's concern. However, they had been doing it in previous years, and I expect that they will be doing it, if not this year, then perhaps next. Anyway, this article explains the 2019 model and gives a little map here of the Tennessee Tech campus so that a person with this document in their hands at that time in 2019 could have walked around the campus and seen all these various objects. We're going to take a look at that a little bit on Google Earth, just for fun. So here we are on Google Earth, and we are in Cookeville, Tennessee, home of Tennessee Tech University, and we are looking down at the Volpe Library. They have a small ball in the Volpe Library that represents the sun. And if we look at their little map, we'll see that, let's see if I can zoom in on this. We'll see the Volpe Library, we see the sun in the middle. In the same room inside the library, there are other small balls. They are tiny, like a half a millimeter in size. The Mercury ball is a half a millimeter in size compared to the sun. And then Venus and Earth and Mars are all right there in the same room of the library. And then beyond that is the asteroid belt. And then we scoot out a little farther. We're now outside of the Volpe Library, and we see Saturn and Jupiter out here. So let's go to Google Earth. That puts Saturn and Jupiter. Here's the Volpe Library, top of the screen. All those inner planets are inside the room of the library. Saturn is here with Brown Hall, and Jupiter is also where this building is, where I'm circling the mouse. And then let's see, Uranus is just before that quad there. Uranus seems to be, there's the quad, there's the loops out here, there's the library, Saturn and Jupiter, Uranus is here. And then we have Neptune on the other side of that quad. Neptune is, zoom out a little bit more, down at this end, bottom of the screen where I'm circling the mouse, where it says South Hall, that's Neptune. And then we've got Halley's Comet in the Kuiper Belt. That would be, double check that again, right in front of these buildings here. No, right on this side of the parking lot. So there's the library, 4 inner planets, and then we've got Jupiter and Saturn, Neptune, Uranus out here. Now we're out here in the Kuiper Belt. And we continue to zoom out. It's hard to see the library now. Where did it go? There's the library. They don't show Pluto on here. All right, well, that gives you a little sense of the scale. So there's the library where I'm circling them. So here we are back at Tennessee Tech on Google Earth. We've got the library at the top of the screen where I'm circling the mouse, and down here at the bottom of the screen, we've got Neptune. Let's take a look at what that distance is. In feet, it's about 1,750, 1,780 feet. So, and in meters, that's 542 meters. Okay. And in the library is a ball representing the sun. And out here, 1,700 feet away, is a ball representing Neptune. And those balls are to scale. And the sun, according to their little brochure, bring it up again. According to their little brochure about the 2019 model, the sun, in this model, the sun you see in front of you is about 14 centimeters or 6 inches in diameter. So to scale, on the University of Tennessee, on the Tennessee Tech University campus, you had in 2019, and I hope again in the coming year, because they do it every year with the exception of last year, a to-scale model of exactly what you asked for, Super Dave. You asked for it and it was there. You asked. Please provide an actual scale model of the Earth, Moon, and Sun. Globetrotters had 500 years or so and still waiting. Well, you didn't need to be waiting. You could have seen it years ago if you had bothered to look, which you didn't. But you know what we are waiting for, and we have yet to see? An accurate to-scale map of the flat Earth. We've been waiting for quite a few years as well. You see, it needs to be a map that has a consistent, regular scale in every direction. So we don't want to have something where the scale is changing in different parts of the map. That's not a flat map. We want a map that shows the Earth where you can pick any 2 points on that map, measure the distance using the scale, and then measure those actual 2 points on Earth, and it will match the map. Any 2 points. And you can do that as many times and as many points as you want. Now, I know it sounds like I'm asking for an awful lot, even though it's what you've already asked for and been given. But in fact, it doesn't need to be a highly detailed street map of every city in the world and all that. Really, all you need is like a good landmark. For example, an airport, that would be a good landmark. Airports, major airports around the world. In the, say, 50 major cities, make sure to cover every continent. A few cities on every continent. And you get the distance from each airport to the other airport. And you can make a map out of that. And if you can make a flat map out of that that actually works, then there's something to talk about. Yeah, then there is really something we could actually talk about. Until then, though, there's nothing. You can talk about relative density. You can talk about gas in containers. You can talk about, moonlight giving off cool light. It's all meaningless if you can't make a map of a flat Earth on a flat piece of paper. So we're waiting and waiting and waiting. Anyway, Dave, Super Dave, thanks for the excuse to make this video. Hope you have a wonderful evening, everybody. I hope you enjoyed this. Good night.